Okay, this is Dr. Williamson. I'm going to show you briefly the thinking behind the solubility chart, or excuse me, the qualitative analysis lab. Let's say I have here my test tube with my unknown. I'll do U, or it has my unknown in it. Okay. And in the first step of the lab, I put in 6 molar hydrochloric acid, HCl, which, remember what I taught you guys, that's code talk for primarily 99% water, right? And then a bunch of chloride ion and a bunch of hydronium ion that I'm putting in there. Okay. Well, when I add that and I look at my solubility chart, okay, I see that if I look over here, all chlorides are soluble except for silver, mercury, and lead. So if I get a precipitate down here, after I add the hydrochloric acid, I know my unknown had either silver, okay, or lead ion in there. They're not giving us any mercury in this lab because mercury is pretty toxic stuff. So what I'm going to do is I'm going to centrifuge those, and I'm going to keep the supernatant. That's the liquid that's on top. And I'm going to test the precipitate with not a flame test, but I'm going to test it with concentrated ammonia. And I believe, if I remember right, ammonia, silver is soluble in ammonia, concentrated ammonia. I believe it's soluble. And lead ion, Pb2 plus, is not soluble in the presence of ammonia. This makes a complex ion that's soluble in water, and this does not make a complex ion that's soluble in water. So I put here S for soluble, and this is not soluble. Okay, and that's how I can distinguish between, if I got a precipitate, that's how I'm able to distinguish between whether I got silver or lead. Okay, so I'm going to erase this stuff now. And now I'm going to look at my supernatant that was on top. In this phase, I'm now going to add ammonia here to make sure it's basic in H3. And then I'm going to add ammonium carbonate. I'm going to type that because it's a lot to draw. So I'm also going to add here NH4 2CO3 and add ammonium carbonate to that. And if I look at my solubility chart here, the carbonates, they are all not soluble. They all form precipitates except for these guys. So if I get a precipitate in here, if I get a precipitate, I know that precipitate is either going to be barium 2 plus or calcium 2 plus, because that's the options from our lab, right? The options from our lab is we may have barium or we may have calcium. Okay. And then what I'm going to do is I'm going to centrifuge. Here, remember I centrifuged, so I'm going to write cent. So I centrifuged, and here I centrifuge again. And when I centrifuged, these guys I tested. Well, that's not what I wanted to draw. These guys I tested with a flame test. And the flame test let me separate between barium 2 plus and calcium 2 plus. Okay, guys? And then choose different color. What I have left over here is the supernatant here, and that supernatant has either potassium left or sodium left. And I test those. Now, there's nothing I can add. If I look at the solubility chart over here, all sodium and potassium salts are soluble without exception. So there's nothing I can add to this to make them precipitate. So these I'm going to have to do a flame test. And that will let me distinguish between potassium, and sodium. That's the logic behind the thinking here. Okay, guys? Because remember, our choices in our unknown, we may have, this is supposed to be right here. This is supposed to be here, silver. Remember, our unknown be Ag plus Pb 2 plus barium 2 plus. Remember, I told you to change the barium to 2 plus, barium 2 plus, calcium 2 plus, sodium, or excuse me, potassium, and sodium. So we could have anywhere from 2 to 4 of those, and that's how we distinguish between these. Okay, guys, that's and that's basically how it works, and that's how we use the solubility chart to distinguish. Okay, so I hope that helps, and I'll make more stuff to help you guys later. Okay, then, bye.